Hey, my name is Igor, I'm a full-time software engineer, and in my spare time I'm building a startup from scratch. The idea is a high-performance URL shortener with a minimalistic, clean and modern UI. My goal is document the entire process, from drawing boxes on the whiteboard to writing actual code, dealing with trade-offs, bugs, and all those moments where things don't go as planned. So if you're into engineering, you're in the right place. Thank you so much for clicking on this video and hope you enjoyed. Welcome back, boys. So last week we designed our redirect analytics on the whiteboard, and in this video we are gonna dive into implementation details, bot traffic detection, tracking optimizations to make our database size predictable, and also I will show how my backend can handle thousands requests per second without losing a single redirection count. And eventually we are gonna try to prove it with the load test. Alright, so let's jump right into it. So I'm gonna go through it the same way as we designed our diagram, starting from the redirect controller. So here is this guy. First thing that we do, we fetch the short link entity by the key and return it almost immediately, with one exception. Now we have record redirect, and what this one do is it builds a context object based on the request itself and pass it to analytics service, and analytics service process that asynchronously. This basically helps us to not keep the user waiting till the analytics processing is done. To simply put, it's running on the separate thread. So we need to parse and analyze the user agent header, and to help me with this, I use a library called yet another user agent analyzer, and a part of the getting the device and operation system information, it also allows to validate whether it's coming from a bot or from not a very good person that tries to break your application. And speaking of bot traffic, I've just recently learned that more than 51% of all traffic on internet are bots, and that includes search crawlers, AI bots, scrapers, and so on. So basically, if you're seeing some activity in your application, it's not necessarily means those are real people. So yeah, I've decided to not include bot attribute in my analytics record because simply it's not useful for me, and I think that one only pollutes analytics metrics. And still, I'm curious how often we will receive those requests, and I've put logs for both of these cases. And what's great about Flogger, it has built-in rate limitations, so even if I receive 1,000 requests in a single minute and all of those are bot agents, Flogger will log it only once. So here is the user agent analyzer service, and here is the way how I configure that. And there is an option to add YAML rule to the analyzer builder, and what this does is basically it allows you to customize the analyzation process of the user agent. And for better bot detection, I got this idea to improve the configuration and pass here the most up-to-date list with common bots and crawler agents. And there are resources that are updated weekly, so one of those microlink, and they have a public endpoint to get most commonly used user agents. And here they have two lists for AI bots and crawlers. So I thought that on every application startup, I can make this request, fetch the list and set it to the YAML rule. And after a couple of hours to make it compliant with the YAML rule structure and automated on the every application startup, I ran a couple of tests and I realized that it messes up with the real device user agents and marked them as the bot one. So I thought screw it, because it took too much time to make it work, and at that point it felt like an overkill for the project. And on top of that, this library is good enough to detect whatever I need. I just need to keep an eye on the new releases. And if you wonder how those user agents look like, so this one is Google Search Crawler and this one represents OpenAI ChatGPT bot. And now let's run our application. I'm gonna put the breakpoint where we get the analyzed data from the library. So I will replace the real user agent with Google bot one. And the library says it's a robot and operation system is Google Cloud. And now let's try the same with ChatGPT one. So yeah, it's also a robot. And as for the malicious user agents, here are two examples for those. It seems that both of those are targeted on the database level. I assume it would try to do some SQL and injection. And what's interesting about the second one, it pretends to be a Googlebot user agent, but at the end it appends a command for database to make it freeze for 5 seconds. So yeah, that's not great. And let's try those two. So again, the library did a great job and it detected that's probably the user agent is coming from a hacker. And now let's try the second one. Yeah, it did the same great job. All right, and then I get the device and operation system types. And for these two, I merged the values into consolidated groups. So for example, for the device, I treat the phone, tablet, and mobile as a mobile, desktop is desktop, and if I get anything else, that might be some wearable or maybe TV or gaming consoles. Yeah, so all of those go to the group other. And if for some reason there is no way I could fetch the information, I just get the default user agent info object with the unknown values, because I still want to register that redirect event. A quick word from a partner of this video, Tesprite. So I keep recommending these guys because their agent really helped me to cut QA time in half. And they just shipped a feature that makes adding test coverage actually fun. If you're not familiar with Tesprite, it's an autonomous AI testing agent that automatically generates test plans from your product requirement document and code, writes and runs end-to-end tests for both front-end and backend, debugs failures, and even suggests fixes. So they just rolled out an awesome real-time test progress monitoring with detailed insights and in-place editing. You can fine-tune every step to match your exact requirements during live runs or subsequent reviews. The moment you run your tests, it opens a live dashboard where you can watch every test case run in real time. In here you can see instance status updates, filter or sort however you want, and search test case by name. And if some of the tests doesn't behave exactly how you want, you can jump in and submit modification requests directly on the dashboard or with a simple prompt. If you're testing front ends, APIs, or full stack applications, this saves a ridiculous amount of time. And the best part, their starter plan still gives you 400 free credits at no cost for the first month. You can find the link in the description. And thank you to Sprite for supporting the channel. Right, and now back to the main video. So the user agent part is done. Then I need to get the country code from the client IP. For this, I use GeoIP-Lite database from MaxMind, and it can be downloaded and used locally on your machine. So in this comparison table, they offer in the Lite, which is free version of the database, they offer two separate databases, one for country, one for city. And that's all I need because I don't care about internet service provider. I don't care about other stuff because I don't want to track the exact place where you're located. I'm not a creep. Yeah, I just care about country and that's it. And what's cool about this database, at least from their documentation, they update the GeoLite country database twice a week. So yeah, that's pretty much what I need to get accurate country detection. For now, I stored the file along with the project and it's loaded in memory in the application startup. And I'm thinking about moving this off the project to some external storage and fetch it every time when I start the application. All right, so we got our user agent information. We have a country code of the user, and the only last piece in this puzzle that left is the refer. And in the last video, I didn't know what to do with this one because it was too scary to allow any host names as a referrer header when some not very good guy can literally send thousands requests per second with randomly generated referrer header, and that might cause a lot of troubles. And at the same time, I didn't want to drop this idea because it sounds like a very good piece of information for the analytics, and that would give you more insights on the source of redirect from where the click was made, whether it was clicked from the YouTube or Instagram or TikTok or Reddit. So eventually I came up to the same solution as for the device and operation system. I will support only a limited number of the referrers, and here I have a mapping of the host name to the name of the resource. So let's say if we receive these two host names that basically point to the same YouTube, it will be treated as YouTube and recorded as YouTube, not product as the host name. And if the refer header is empty, it only means that user just grabbed the short link, put it in the browser search bar and press enter. So it means it was a direct request. Now we finally have all we need, and we can build a key that after we can use for the redirect incremental operation. And as I explained in the previous video, I want to accumulate the redirect count in the cached-based counter with the aggregated keys. And this is exactly what I'm doing here. And with this key, we add to our counter +1. So the counter in general might sound like a trivial task, and indeed if you're incrementing that once a minute, there is no need to over-engineer it and come up with a simple solution or just increment it directly in database. But let's say when you need to increment it thousands times per second, obviously there is a risk of losing some counts if the synchronization is not done properly, because you're not querying the database for every count. That's not efficient, and you need to accumulate that in cache. So yeah, the increment operation should be the atomic one. And the same applies to my method drain all. That one I use in the cron job that pulls all the data from cache and flush it in database. So here is the scheduled cron job, and I need to get all the counters with aggregated keys and store it in database. So what I did here is that I have my cache as atomic reference, and when it comes to the drain all method invocation, I create a new cache, and then with this atomic reference I get the old cache and right away I set the new one, and this one is done in the single operation, so there is no way you will lose any redirect counts during this method call. So after this line is called, the new cache is served as a main reference for the increment, so any new redirects will be registered in there. And as for the old cache, I can do with that anything I want without interfering with the new data that comes. Right, so I get all the entries, and for each of those I call the analytics record service, which will call database under the hood. And here is the database query itself that updates our counter in Postgres. And what's cool about SQL is that query is also atomic, so if the database receives two queries at the same time to increment the same counter, it will be executed one by one, because database locks raw on every write. And to get a better picture on what is happening during this database increments, let's imagine that current counter value is 10 and database receives two concurrent queries. One is trying to increment it to 5 and the second is trying to increment it to 10. And let's say the increment +5 was received on a fraction of the second earlier, so it starts the transaction and locks the raw for the write operation. And at this moment the second query also starts the transaction, but instead of doing the same lock, it's just waiting till the first transaction is finished. And when it's finished, it unlocks the raw, counter value is 15, and after the raw was unlocked, the second transaction can do its lock, increment the counter by 10, and eventually we are gonna have 25. And what's awesome about these locks, it's only affected on the write operations. So if you're trying to fetch something from database, by default you'll get the last committed data. Right, so everything is ready, and now let's have some fun. So what we're gonna do next is we'll run a couple of load tests and we are gonna try to break the application. Or not, yep. I hope it won't break, and at the end of the tests we're gonna compare the total amount of iterations that went through the load tests versus total amount of the redirect count for a single short link. So I'm gonna log into my account and create a new short link. For the destination URL, I thought that I need to find the most efficient resource, the one with the lowest latency. So fortunately for me, there is another Google URL that I wasn't aware of. So it's like google.com/blank HTML, and it returns exactly what you would expect. It's basically a blank page. The content in 0 bytes. The response time took 94 milliseconds. So yeah, we are gonna use this one. All right, so we have our short key. And as for the tool that I'm gonna use for the load testing itself, it is K6 from Grafana Labs. and I found it way easier to start with than the tools like JMeter. So the main idea is to write the load test in JavaScript. So here's how my JavaScript file looks like. I came up with the test data and I need to replace our short URL key. I'm gonna save that. And as for the test data, I have an array for referrers. I have an array for IP addresses for different countries, and also a bunch of different user agents. And all of that is gonna be picked randomly. So here is how I generate the headers. Then we need to define the options for the tool. And here I have a target request per second. We have thresholds for the success and failure criteria, and basically the test request itself. All right, so let's run this test, and we're gonna start with the 100 requests per second, and the test duration will be 1 minute. So I'm gonna start that one. And here you can see the total number of combinations are 7,600. All right, so the test is finished, and now let's check the results. So the total number of requests were 6,001, and the longest request took 49 milliseconds. So yeah, and now in theory, this number should match the total count of all redirects that the application should register. And to confirm that, I have an SQL script that do this exact calculations for a given short link ID and within a single day. So if we're gonna run that, we receive the exact same number. Yeah, this is so cool because it means that my application doesn't lose a single redirect and they are all registered in the database. And here is how the data looks like in the database itself. So here we have a date, country, device, OS, refer, and redirect count itself. So yeah, this is so sick, it works. And now since 100 requests per second test works flawlessly, we're gonna try 1000 requests per second. And also I'm gonna add a couple of environment variables. So this one allows us to see the metrics of the test execution in live. And this time I'm gonna run the test for 5 minutes. But before that, I need to clean the table from the data so we could compare the total number of redirect counts. All right, so this is done, and we are gonna start this one, and we have a link that we can open in the browser, and we can see the execution metrics here. The iteration rate is around 1000 requests per second. Also, we can see how many data we're sending and receiving, the request duration, so it's like under 20 milliseconds, which is awesome to see. All right, so the test is finished, and let's see the summary. Yeah, and for this test, the maximum request duration was 251 milliseconds, which is a bit higher than the previous one, but still is a great number because again, we were sending 1000 requests per second. And the total number of iterations this time was almost 300k requests. And to get the more precise number, we are gonna grab this. So the database total redirect count should match this one. And we are execute the same query as before. And now let's compare these two numbers. Oh man, it's exactly the same. Wow, this is so crazy. Yeah. These moments make me super happy because even with the simplified architecture, the application works flawlessly. And when I expecting something and it delivers the exact same results, yeah, it's an awesome feeling. And actually, I just realized that my application doesn't even have virtual threads enabled. And it's crazy it delivers these results without those. Okay, so for the last test, I want to do something that might break the application. I want to do a spike traffic test. Imagine that the link was placed in some viral post on TikTok or something like that, and 5,000 people per second are trying to accessing and being redirected through that short link. So we are gonna try to recreate the same scenario. And for the test duration, I'm gonna let run for 1 minute, and our PS count are gonna be 5,000. But this time I'm gonna enable virtual threads. And now let's clean our database one more time. And now let's run this guy. All right, so we already have some data, and the request rate is 5k, which is sick, but we're gonna let it run till the end and check the results. All right, so it was completed. Yeah, and I already see that the maximum request duration this time was 2 seconds, which is kind of expected. And at this point, you would wanna have at least 2 or 3 instances to spread the traffic among them. And the total iterations, let's check it in the terminal and let's compare it again. Wow, the number number is exactly the same. I wonder where the errors are coming from. The application didn't produce any errors at this point. Yeah, this is crazy. All right, I'm gonna do one more, just one more tests, because I really want to break the application, and it seems it not that easy to achieve. So we are gonna have 10,000 requests per second, and the duration are gonna be, let's say, 2 minutes. So yeah, let's do this. So we finally did it, and the application seems not like break, but it started to responding super slowly, and from the logs I don't see any errors, but I think I know where these errors are coming from. So errors are depending on the threshold that you configure in the K6 tool, and basically if the request is taking too long, it would count as a failed request. But again, I'm extremely surprised that the application was able to receive 10k requests per second for almost 1 minute without any change in the duration. Yeah, so here is when it started to get worse, but right before that, the average response time was 148 milliseconds, which is great. And the longest request took almost 500 milliseconds. And let's see the summary. So in total, the longest request took 24 seconds. Yeah, that's not great, but again, we were sending 10k requests per second. Yeah, I cannot just realize that, but this is crazy. And the total iterations are 720k, and there are no 400 or 500 errors at all. The total percentage of the failed request due to the request duration is almost 25%. All right, so to conclude this break-in test, I'm gonna take this number and compare with our SQL query. So here we have almost 500k redirects, and the actual amount of redirections were 200k more. Yeah, I guess if we subtract around 24% of errors from this amount, we will get something like this. So overall, I am very happy with the results, and to be honest, I would be happy even with 1000 requests per second, but as we saw, the application is relatively stable even with 5k RPS. So yeah, that's awesome. Alright, so that's about it. That's all I have, and I see you guys in the next one.